All right, welcome back to another set of questions trying to figure out, can we score points? We're looking at the 2022 AP Physics C exam. This is problem set number 1. This is, if I recollect correctly, the 2021-2022 school year. This is the first year we had an in-person exam since COVID. We did the online test the year before, and then during COVID, it was the weird online test. And this group didn't do particularly great, unfortunately. Globally, it was not a great, highly scored exam. There's some tricky questions, but let's go ahead and take a look at them, 3 of them individually, and see if we can figure out where we can score some points. So let's get the timer going and start reading. All right, so we've got a situation that looks great in terms of complexity here. It says a block of mass M is pulled across a horizontal table by a string connected to a motor that is attached to a floor. All right, the string passes over a pulley with negligible friction that is vertically aligned with the left edge of the table. The string and pulley have negligible mass. Okay, so that means there's no I in this case. Sorry, that's off screen. There's no rotational inertia for that, which is good. The pulley is at height h above the table, and the motor exerts a constant force of tension Ft. The block remains in contact with the table at all times. That's interesting, even when it gets to here, it doesn't get picked up. Okie dokie. As the block slides across the table from L to 0, the coefficient of kinetic friction between the table and the block is mu k. Express all answers in terms of this stuff. So it's being pulled along by a string that's connected to a motor. All right, no question. Spent over a minute just trying to read it. Question A. On the dot below, draw all the forces, not components, that act on the block at x equals L. Each force must be represented. Okay, so it should have weight force, okay? Let's go and draw that in here. So we'd have the force M times G. It is being pulled by a string, so there's going to be some tension force there. There's going to be some friction force acting against it. And I'm not drawing these particularly well to scale. And there should be a normal force acting up. I know this is bad, but those two should add up to the same thing as mg because it's not accelerating off the ground. So you'd want to draw that better. But let's take a look at part B. Derive an expression for the angle theta as the string makes that the string makes with the horizontal as a function of x. An expression for the angle theta. So going back up here, there's theta. Hello. As a function of x. Well, this is x0. That's x equals L, so the x-axis seems to be along here. So if x changes, theta changes. It seems like we'd be using triangle math, right? Triangle math. So let's see the relationship here. X and theta would be related by the height. So maybe let's write down tangent equation here. So we can say that tangent of theta, opposite over adjacent, right? So that would be x over h. And then arctan. Shouldn't be solving this. Should just be setting things up, but I think that's all that we can get on for that. Let's see here, part C. Derive an expression for the normal force N exerted on the block by the table as a function of the block's position x. Okay, net force equation. They're asking us to solve for a force. So in the y direction, we'd have normal force plus the tension force sine theta component minus mg would have to equal 0. So that's my net force equation for that. And we want a function of normal force in terms of x. We're gonna have to like do some sort of subbing or something like that, which we're not gonna do right now. We're gonna move on to C2 and see if we can set something up for that. Derive an expression for the magnitude of the net horizontal force F net exerted on the block as a function of the position x. Okay, again, it's position x. So in this case, in the x direction, the net force we would have let's say negative tension force cosine component plus the friction force, which would be equal to m times a. I guess is it accelerating? I guess it could be accelerating. Didn't say it wasn't. So we could set that up, but again, they want it in terms of x, so we're gonna have to sub something in there. Anytime you have friction, you can always say that it's gonna be mu times normal force. That could be worth some credit. But we'd have to sub in, so the normal force here, we'd have to plug in, and we haven't solved that yet, so we can't finish that anyways. Ooh, 10 seconds. D, right, but do not solve an integral for the expression used to solve for work done by the string on the block. So the work done by okay, so this sounds like an integral. Work should be the integral of the force dr. And in this case, if it's work done by the string on the block, that would be the tension force, right? The tension force, but the tension force is cosine component multiplied by dr, and then going from L to 0, something like that, maybe. I know we're out of the 5 minutes, but then it goes on, that's question 2. So yeah, we'll not worry about that right now. So yeah, it looks like we've got 5 minutes in. What I'm gonna do now is pull up, if I can, the rubric and see how we scored on this. All right, I pulled up the rubric here. And let's see if I embarrassed myself at all, getting things wrong, but part A. Free body diagram. For correctly drawing and labeling the force of gravity and the normal force of the block of mass m, 1 point. All right, cool. We got ourselves a point there. So +1. We did that. For correctly drawing and labeling a force of friction on the block, yeah, okay, +1, sweet. For correctly drawing and labeling a force of tension on the block, yeah, cool. Well, we got 3 points. Look at that, 3 points. By the way, I got the scoring statistics right here. The mean value for this problem was 7.25, so we're almost halfway there. Then scoring notes, so there's a bunch of stuff here. I'm sure it's about the sizing appropriate stuff, but let's go on to part B. Part B said for trigonometric expression relating the angle to the horizontal distance, so just having a trigonometric for any correct trigonometric expression. Okay, so there's 2 points for that. One is just saying that you're using trig. Well, sweet, we got that one. And then, because, I mean, I'll be honest, I know this problem. I've worked it out before, so in the back of my head, I probably knew what I was supposed to do there. For any correct trigonometric expression, so, but I didn't do it right. Yeah, do you see that? I got the trig upside down there. It should be h. Oh yeah, I said, yeah, see, I don't get that point. So Zook made a mistake there. Okay, so we're at 4 points. First point, or maybe I didn't get that first point. Yeah, I guess I wouldn't because I got that upside down. Okay, so take that away, bad boy. C, let's see what CI says. For Newton's second law, showing the vertical direction sum of forces, that would be 1 point. Okay, so something like this, looks like I got that. So we're up to 4 points total. And then for solving it for Fn, and as you can see here, having to sub in for the sine theta, you'd actually have to put in a, that looks like for sine theta, you're doing opposite over hypotenuse, and they're calculating the hypotenuse using Pythagorean theorem. That's all 1 point, all that 1 point. But it'll pop up down here again, it looks like. So for C2, for setting up an equation with tension and friction force, looks like we get that. And for correctly substituting a component of the force of tension, so putting in the cosine, you get a point as well. Sweet, okay. So correctly substitute expression for the normal force from part, so we didn't sub in the normal force, so we get 2 here, because we got an equation for that, and we got the equation for subbing in the tension force component. At least that's how I'm gonna call it. And then part D, I wrote down that we're gonna do the x component of the tension, dx, so I said dr here, but I don't know, I think that would be worth a point. for using horizontal component of the force of tension. This is either 1 or 2 points right here. That's not bad. And then didn't even look at this one, so we're not even gonna look at it, but it seemed like all these required to use some sort of substitution in for the angle theta. And let's go ahead and do a scoring, see what we got, worst case, best case. So 1 or 2, 3, 4, 5, 6, 7, 8. 8 or 9 points out of 15 after spending about 5-6 minutes on it. Again, I could have done this better if I knew my trig, if I remembered it, but not bad. So let's pause that one and we'll take a look at FRQ number 2 next.